All right, let's talk about the other side of multi-threaded code. My name is Ryan Avery. I've been an audio developer for a long time now. I started at Avid working on Pro Tools, ADCx, ADCx plugins. I moved on to Dolby where I worked on Atmos spatial audio content creation. Now I'm at Apple. I'm also, like a lot of you, a independent musician. I'm a violin, electronica music producer, so I love this industry, and I now know a thing or two about it. And I wanted to talk about the testing side of multi-threaded code, because thank you, Palmer, for showing that this is complex stuff. And this is stuff that you get far in your career, and you still are learning things. In this talk, some expectations. We're not going to worry too much about production code. We're going to focus on the testing side of things. We're not solving this either. This is not a solvable problem. We're just adding a few more tools to your arsenal. In fact, we're going to show some really bad multi-threaded code. Don't use any of the code that I'm showing you. There are no magic bullets to test this, but with a few simple tools, we can kind of start taming this system. So of course, that brings us to castles. I love analogies, and I want to talk about castles because we build castles as a series of fortresses to keep order, make things run efficiently, hopefully keep our townsfolk safe. Multi-threaded code is the same thing. Helps things run efficiently, allows us to scale up our processing, and hopefully keeping things safe in the process. But the thing about castles is, whenever castles exist, so do dragons. In fact, the larger your castle, the more dragons are attracted to it. Dragons are powerful when they work with you, but very dangerous if they get out of hand. Multi-threaded code is the same thing. There's always the possibility of being killed by a dragon. And the larger your concurrent multi-threaded code base, the larger that possibility, the larger that dragon. So here's some really bad dummy code. Again, don't use this. It stores some samples, uses a max and a background update thread. You can see two threads going on here. Process and update, we've all seen this, simple stuff. There's bugs here, obviously. It's pretty easy to reason about. You can probably see several problems, but remember, we're not concerned about this code. This is production code. But hey, look at that. It's a little baby dragon. It's this little max float here that goes between the two threads. It's easy to think about and reason with. It's very small. It's cute. It's a little pet. You can probably fix this code in your sleep. Or not, don't care, you might be just getting into multi-threaded programming. But as it grows, it can be a big, big problem. So we have to tame it. How do we deal with this dragon? We have 4 ways. We can ignore it, pretend it doesn't exist. We can stress it. We can force the dragon to keep attacking our castle to see where it interferes. We can cage the dragon, give it a smaller little castle to play with, to attack, Or we can mock it. We can place a puppet and say, oh, dragon's coming, oh, it's gonna attack us. We'll talk about these things in a bit. But remember, the dragon is that magic that makes multi-threaded code so powerful. We want the dragon. We need the dragon. We can never kill the dragon. The dragon's always gonna be there. So, first, ignore the dragon. Just write some single-threaded tests. If you don't currently have tests in your code because of threading, then just put some in. Pretend it's not threaded. Don't worry about concurrency. Most tests should not be thread aware. So here's a simple test. It's valid code. It says, oh, okay, we have this little test function that says, oh, 2 blocks coming in. The max of both of these blocks should be 1 because we wrote this little max meter function. Now, of course, everything is serialized in a single thread, so we have no idea what the code will do if both threads are concurrent. But it's still a valid test. Now note, you can't always ignore the dragon. For instance, if, let's say process and update are async, but in general, you can ignore your dragon and just say, we don't care about the dragon right now. We just want to focus on our logic. Next, we can stress the dragon. You can run your code a lot of times, see if it fails. Now, we could just do manual tests on the real system, but the problems we're looking for are very, very rare. These are the things that customers will find and say, oh, it crashes my system once out of every 1 million things, and you can never find this bug. These are the kind of multi-threaded problems that we're trying to tackle and tame. And in general, you should prefer the smallest reasonable test size. We don't want to have tests that run, manually via a QA engineer. We want this thing to be a few seconds on our test system. Now, with modern C++, it's very easy to instantiate threads, especially in tests. So here we have, our two threads. One is our update thread, and one is our process thread. We can just instantiate this in a test. It will run. It will go a million times, and usually, if there's a bug there, it will find it. Now, of course, some of the more obscure ones and things that are much more rare might not be found by this, but it's, again, a valid test. It's not going to test your logic. Like, this assertion completely will not pass. This will fail because we don't know the order of our two threads, how they're, we don't have determinism in this system. But here, this is more an example of, testing your threading rather than your logic. So we can cage the dragon. We can separate our test concerns. We can define our thread interactions, and this will give us more concrete entry points. So going back to our unsafe mirror class, we have lots of references to max sample here, and we can start seeing, like, the dragon is in more places than we might like. Like, there's 4 references here. There's even some comments for code we have written but commented out here. That's a lot of places the dragon can live. So we want to, limit where this multi-threaded entry points, these multi-threaded interactions are. We need to separate the logic from our async code. Part of it deals with correctness of the overall logic. The other deals with async interaction. We need to limit it to defined points. Start constructing your API around your multi-threaded nature so that most of our tests don't deal with the dragon. They don't deal with the multi-threaded nature of our code. We can get our dragon out of what we're testing for in most scenarios, or at least know where the dragon comes in, and we're in better shape. So how does that look? If we have kind of a safer meter, we have this thing, it's a little queue for meter. We recognize that, yeah, we probably have a queue that we need to do interactions with our threads, and so we'll put it somewhere. Again, this is all hand-wavy, really bad code, but we start to recognize where the dragon is, where our threads interact with each other. And we start boiling it down to simpler data structures, queues, stacks, condition variables, simple things as much as possible. Isolate the uses of our thread-aware variables to as few methods as possible, extract into a separate class. Here can we extract store max, get max in this queue for meter into this thread-aware class, and leave the rest of our process function and update function blissfully unaware of the dragon. The more of the class is testable without being thread aware, this is good. We can write tests easier this way. Now, some known cages. Once you have these known cages, we can do things like, hey, a queue. There's ways to test for the dragon. We just say, here's 2 threads. Assert that this thread puts stuff in the queue and it comes out the other side on the other thread in an expected order. If we have a stack, we assert that there's no missing elements if we put a bunch of elements in a stack in one thread and take them out on the other side. We can expand that for multiple input, multiple output, consumer, producer kind of styles. But I'm not going to go too far into this because there's known ways of doing this online. Objective is to get things into a simpler form. Finally, we can mock the dragon. I won't talk about this too much. This gets into more sort of TDD testing style code. You can look it up online. But this is basically saying that dependencies come from outside. This is this dragon. There's this multi-threaded beast that we want to pass into our classes, pass into our functions, rather than having them as part of our classes. So we might find solutions where our class is waiting, or depending on an outside complex service, we get into discussions like, when do you mock a dragon versus moving a dragon outside a class? It's all subjective. Basically, you start mocking dragons when it becomes burdensome on testing to keep it inside of the class, rather than mocking, which comes with its own burden of keeping tests in order. You make that trade-off. Now, dependency injection simply means this. We have our class to test. We have a dependency. It's our multi-threaded dependency. We just plop it in, usually in the constructor. And this can actually be done in compile time. So usually with mocking, you don't need to worry about performance, although it's something to keep in mind. But I find people tend to worry about it a bit more than they should. So let's look at test code smells, because just like production code, test code has its own smells, its bad sense as well. That could like tell you something is wrong, indicating that production code might not be as testable as it could be. So the first test smell, lots of sleeps and waits. If you're starting to test your code and you see things like this little sleep, 0.1, well, that's a test smell. Tests are taking longer than they need to, first of all, because obviously this 0.1 is kind of just arbitrary. It means you know there's a drag in here. You don't know exactly what it's doing. All you know is it's likely to be done in 0.1 seconds or something that you made up because of, you know, something. It failed when it was 0.01, so why not 0.1? I've seen this a lot. You've probably seen this a lot as well. Tests could still fail under CPU load, and you'll probably maybe increase that value. I'm not saying that, you know, I'm guilty of this. I have been guilty of this, but it's a test code smell and one you want to get rid of. So, a little bit better. Let's wait on a state change. Let's say, you know, we set a host control to 2.0. It's going to wait until that value is actually received and set in the plugin. Well, this is an easy change to make because it usually doesn't require production code changes. But even better still, observers and provinces. We heard about this. You've probably seen this in your code base as well. Let's, you know, actually introspect our code somehow so that we can see, oh, exactly when this value changes in the host. That's when we can move on to our next line in our test. Now, this does sometimes require production API changes, but I would argue that this is good. We want to be able to observe and to listen to our production code. So this is a good change. It's something we might want in the future for UI or whatever. Yeah, there's our promise. There's our future, our waiting. It's still a dragon, but it's a little cute, mandible dragon. Getting better there. Even better, let's just put it in a test helper function. Set on host and wait. That way you don't have to read all that boilerplate code. It's just one line function. But as you probably see, there's still a wait. And we said lots of sleeps and waits is a test smell. So, another test smell. Every thread feels thread aware. It's fine if we're always waiting on events. You know, you set state but have to wait on it to take effect. It's okay, but we want something better than that. Here's our last piece of code. Now, look at this. This test is named plugin can set process, not host can set control. So why would a plugin control wait on a host at all? This is really indicating that there's two tests here that we really need to do. We need some API changes. So we're going to say there's two things. There's plugin test and there's a plugin host test. The plugin test can process. We don't care about how the control update got there. All we care about is that we assert when we have this update. Yeah, it's a gain of 2. And the host just cares about, hey, I get a value that I can set. I want to make sure that actually gets set to the plugin. So we say plugin host can update control. You know, we use tests to drive this change. Got a very powerful side effect on both our tests, but also our usability and our maintainability of code. Cute little baby dragon, but it's still a dragon. So the best situation is stateless code. This is not always possible, not always even desirable depending on what we're doing. But remember, we need the dragon. If we have stateless code here, that's great, but we probably are doing multi-threading because we want to do some sort of concurrency, do some more processing. But if we can get our code to stateless, that's great because there are no dragons in stateless code in terms of multi-threading. So one more test smell, test running in real time. Anything like internal timers, this sucks because it's a variation of bear sleep. We're just, having a test that's saying we can process for some reason we need to run for 2 seconds. I don't know why, but I've seen it in my code. I've seen it in code bases. You might have too. This means this test takes 2 seconds to run. It shouldn't. We should be able to run our tests in faster than real time. So the advantage that we want to go to is dependency injection. And we want to inject our timer into whatever is depending on this timer. Thus, with this one little change, now we can run our code faster than real time in our tests. This is very powerful. Give him mocks. Don't use a real timer. Do a mock timer. We can kind of tick it on our own cadence rather than having to wait for a wall clock time. So I'm going to talk about multi-threaded protection smells just briefly, because this is where we start putting the test-driven in TDD. If we have scattered standard atomic number variables all around here, those are all little dragons. I'm not saying atomics are bad. They're very good. We want them. But remember, every time we have an atomic, that's a dragon. That's something we need to control. We need to either cage or tame or do something to not have it propagating around our fortress, scaring our townspeople. Too often you probably fix a crash with an atomic. We say, just put an atomic. It's, doing multi-threaded. Once you put an atomic there, it's fine. Move on to the next thing. Well, we need to know that that just is a smell, and we need to keep that smell somewhere in its own little thing. Similar thing with scattered uses of atomics. They're all dragons. Put them into its own thing. Just have an exchange. Make sure that wherever you use those atomics, you're doing it with great care and great knowledge. Similar smell, async calls in classes under test. Here we have this update class, which I want you to look at this briefly and say, how do we test update? We can't, because we're starting up a thread that calls update under the hood. With this API, there's no way to test update in isolation. So instead, have an updatable. Use dependency injection. Put it into your class. Thus, updatable contains the audio logic. This my class now is all the threading logic. We've separated our concerns. Things get much more testable. So, lastly, I'm going to say it takes a team to tame a dragon. One of the people on your team is not a person at all. It's this compiler, static analysis instrumentation. I recommend looking these things up. The best time to add a static analysis to your code is right now. Or what is it? The best time was yesterday. The second best time is right now. You know what I mean. These tools are old. They've been around for a long time, but they're very useful in telling you kind of where these smells are, where your dragon can live. Make sure that your dragons stay small. Final points. Most of your tests should be thread unaware. Make sure your thread aware code is separate from your logic code. Distill your concurrent code into these basic structures. Don't just place them willy-nilly everywhere. Remember that the first test is usually the toughest. So it requires refactoring your production code base sometimes to be able to instantiate something under test. But put that first test in there. Think about where your dragons may be. Keep your fortress safe. And now go out and tame your dragon. Thanks.